lecture. Continue the effect of factors on the gravitational force as well as gravitational acceleration. In the last video lecture, we see the points that affect on the Z. That's points along the surface of the earth. There we see the affecting factor of the gravitational force, that is the height of the object from the surface of the earth. Now, third point, that is C point, which is change with depth. You know, our earth is not a vacuum, empty. It is the sphere. Maybe it is not completely spherical, but it is the massive factor. It has mass, full of mass. Then we have to think about the change with depth. Depth means that the interior part of the earth. Suppose it is our earth sphere. Maybe it is a surface, but it has two center points. Center on the surface of the earth and the center inside the earth. Suppose we passes any object from the surface, it reaches at the center point. It is the inside point of the earth. What happens actually, the object is taken to that point. The value of Z also changes. But how it changes? If we go inside the earth, the value of R in equation number 5, that is Z is equal to Gm upon R square, decreases value of R, and would think that in the last point we also studied, we also see that if we increases the height and decreases the value of Z, but here according to that formula, if the value of R decreases, and would you think that the value of Z should increase according to the formula, because height becomes less and objects goes towards the center, inside the center point of the earth for the formula. However, the part of the earth which contributes towards the gravitational force felt by object also decreases. Object also decreases, which means that the value of M, the mass value, you know, if any object in any point on the surface of the earth, the total mass affects on that object But when that object goes to the carry to the inside the center point of the earth, and the mass of the earth that act on that body is become decreases, and the value of m to be used in equation number 5 also, it is decreases along with r, along with distance, as a combined of change in r and m, दोनों में भी चेंज होता है, r में भी चेंज होता है और मास में भी चेंज होता है. The value of g as we go deep inside the earth decreases. You know, there are many heavenly bodies as well as different planets and satellites in our solar system. These all bodies, these all objects, planet, satellites, are not equally mass. Their masses are so different. Some planet in the solar system, they have the natural satellites, like our moon is a natural satellite of our earth. There is a gravitational force, but due to the different masses, the gravitational force is not equal for all. It is related to their size, that means their mass. So, gravitational force is not equal. Compared to our earth with moon, our earth has a large mass, and the mass of moon is less. That is why the gravitational force act by the moon on its surface is definitely less than our earth. Now see it, every planet and satellite has a different mass and radius. It is not same. Now just I told you. Hence, according to equation number 6, G is equal to Gm upon R square. It is equation number 6. That the value of G on their surfaces, any planet, any heavenly body, any satellite, that means on any moon of that planet, all their surfaces are different. On the moon, it is about 1/6 of the value on the earth. That means the value of Z on the earth, the magnitude of the value of Z, and that such object's value of Z on the moon surface is definitely less, and it is 1/6 that of the value on the earth. As a result, using the same amount of force, they stated example what happens actually. We use the force that's the amount on the earth, and that such force is used on the surface of the moon. What happens? Force is equal, but pulling force, gravitational force are different on the earth surface and on the moon surface. What is the result? If you use the same force on different surfaces, surface of the moon and surface of the earth, as a result, using the same amount of force, we can jump 6 times higher on the as compare that on the earth. उसका मतलब ये है, if we jump on the earth using something force, whatever may be height of our jump on the earth, if we go on the surface of the moon and jump with the equal force to the earth on this moon surface, what happens? Our height will go 6 times greater on the moon surface because of the pulling force on the body of the person. It is not safe. So we can jump 6 times more than jump on the earth. उसका मतलब यह है, if we go on the moon surface of the moon, अब सीधा नहीं चल सकते मून पे, हमें जंप मार के चलना पड़ेगा. If we walk on the earth, our footstep easily down on the earth again. We have to use the force to lift our foot for the walk, but it not happens easily on the moon surface. It is the next point. And this is different here because of it is related to the gravitational force of planet or any body. You learned in the last standard, since from 6th class, the concepts and quantities, mass and weight. Actually, mass and weight are the different quantities and different concepts. The mass of the object, which is the amount of matter, how much matter is in that object, in that body. It explains the quantity of matter in the object, in the body, any object. That is why amount of matter in the object. And you also know the unit or the mass in the side. It is kilogram. That is kilogram, and it is in the CGS. It is gram. Mass is a scalar quantity. It is not a vector quantity. To explain the mass, there is no necessary, no direction. Hence, it is a scalar quantity. Its value is same everywhere. It is important factor. If we take something mass, unit mass, from any place, and we carry along with you, along with that mass, you carry it on the moon or any planet, or on the earth, any point on the surface, or any height from the surface. अब जहां चाहे वहां ले सकते हैं, लेकिन it remains the same. The matter in that body, why it is explained it remains same? Because of compared to the weight, compared to the gravitation force act on that massive body, it changes place to place, but mass remains the same. Mass does not change everywhere, it remains the same. It does not change even when we go to another planet also. Suppose it is piece of chopstick. It has something mass, 2 gram, 3 gram, and we carry this piece and goes to the moon, go to another planet. It remains as it is. Particles in matters in this chopstick. There is no question changing it. It does not change. That means the mass, the constant quantity compared to the weight and force. According to Newton's first law, you know Newton's first law, you learned that law in the last year. Some about law we also learned in the 8th class. Inertia. It is the property of the matter. It is the property of the object. That inertia property is related to the mass as well as force, gravitational force act on it. So, Newton's first law, it may measure the inertia. It's called in Marathi Zadatva of an object. Higher mass, higher is the inertia. Inertia. We can say in another word, it is also weight. We can easily handle the light or less massive matter object, but we have to try more. We have to exert more force to move that higher massive object. उसका मतलब ये है जितना भी एनी ऑब्जेक्ट का पदार्थ का मास ज्यादा होता है उतना ही ज्यादा इनर्शिया होता है। और इनर्शिया किसके वजह से होता है? मास की वजह से होता है। बिकॉज The gravitational force of that of planets act on that mass, means inertia is directly proportional to the mass of that body. Greater the mass, greater the inertia, we can say in another word, greater the weight of the body. Weight is another quantity. Weight is another concept. It is the next point. This is different here because of it is related to the gravitational force of planet or any body. You learned in the last standard, since from 6th class, the concepts and quantities, mass and weight. Actually, mass and weight are the different quantities and different concepts. The mass of the object, this is the amount of matter, how much matter is in that object, in that body. It explains the quantity of matter in the object, in the body, any object. That is why amount of matter in the object. And you also know the unit of the mass in the side. That is kilogram. That is kilogram. And it is in the CGS, it is gram. Mass is a scalar quantity, it is not a vector quantity. To explain the mass, there is no necessary, no direction. Hence, it is a scalar quantity. Its value is same everywhere. It is important factor. If we take something mass, unit mass, from any place, and we carry along with you, along with that mass, you carry it on the moon or any planet, or on the earth, any point on the surface, or any height from the surface. अब जहां चाहे वहां ले सकते हैं, लेकिन it remains the same. The matter in that body, why it is explained it remains same? Because of compared to the weight, compared to the gravitational force act on that massive body, it changes place to place, but mass remains the same. Mass does not change everywhere, it remains the same. It does not change even when we go to another planet also. Suppose it is piece of chopstick. It has something mass, 2 gram, 3 gram, and we carry this piece and goes to the moon, go to another planet, it remains as it is. Particles in matters in this chopstick. There is no question changing it. It does not change. That means the mass, the constant quantity compared to the weight and force. According to Newton's first law, you know Newton's first law, you learned that law in the last year. Some about law we also learned in the 8th class. Inertia. It is the property of the matter. It is the property of the object. That inertia property is related to the mass as well as force, gravitational force act on it. So, Newton's first law, it may measure the inertia. It's called in Marathi Zadatva of an object. Higher mass, higher is the inertia. Inertia. We can say, in another word, it is also weight. We can easily handle the light or less massive matter object, but we have to try more. We have to exert more force to move that higher massive object. उसका मतलब ये है जितना भी एनी ऑब्जेक्ट का पदार्थ का मास ज्यादा होता है उतना ही ज्यादा इनर्शिया होता है और इनर्शिया किसकी वजह से होता है मास की वजह से होता है because the gravitational force of that of planets act on that mass means inertia is directly proportional to the mass of that body. Greater the mass, greater the inertia, we can say in another word, greater the weight of the body. Weight is another quantity. Weight is another concept. Now see the another point. It is came along with mass. You know, every body in the universe have the mass, and on that mass there is a force act on that body, act on that particle, so and it get the weight. Weight is a, maybe it is a quantity, but it is related to the mass and force act on it. It is said or it is defined as the force. It is a force with which the earth attracts the object, and it is on the object of the earth. Maybe object on other planets, on the satellites. They are also for weight. So, the weight of an object is defined as the force with which the earth attracts the object. Every body, every object has get a weight due to the attractive force of the earth. The force, it is represented by a symbol. on an object of mass m on the surface of the earth, whatever may be object on the surface of the earth, it has a weight, can be written using equation number 4. And that is it. Weight, it is denoted by W. It is a one type of the force, and due to that force, the body gives a weight, and that is F is equal to mass into gravity, gravitational acceleration of Earth. G is equal to Gm upon R. Weight being a force, just I told you, its SI unit is Newton. That is why maybe the force and weight are the different quantities, but they are explained with same unit, Newton and time. Because the force and weight, we can say it is the both sides of the same coin. They are not basically different from each other. Due to the force, get weight, and due to the weight, make force. Also, weight being a force is a vector quantity. Force is a vector quantity, and due to the force, body object get a weight. It is also because of the weight get to the object due to the attraction force of the earth. That attraction force towards the direction of the earth. That is why it is a direction. So it is a vector quantity, and its direction is toward the center of the earth.
According to Newton's gravitational law, the gravitational force gets stronger as larger masses two bodies have and as smaller the distance between the bodies get. We are much closer to the Earth than to the Sun. Because of this, we are more attracted to the Earth. Even the Sun has a much larger mass. But how strong is then the gravitational force exact in Earth's center? You probably won't believe it, but it's actually equal to 0. If you want to know why, stay here until the video ends. The mass of the Earth is distributed over its entire volume. All parts of this mass have own fields of gravity, which combined together results in Earth's field of gravity. Let's see now how the gravitational force is changing for an object that moves from Earth's surface to its center. At a certain depth, we can divide the Earth in two parts, the spheric part below the object and the rest of the Earth in form of a hollow sphere. The hollow part attracts the object in all different directions, so for every force in one direction exists another force in the opposite direction. And assuming that Earth's density is constant, we can get mathematically that those forces are equal, and due to this the resulting force from this part is 0. The part below acts as a smaller Earth, and due to the smaller mass, it attracts the object with a smaller force as well. On this way, as closer we get to Earth's center, the gravity gets less intense. When the object is exact in Earth's center, it is obvious that the object is attracted in all different directions equally, so the resulting gravitational force is combined equal to 0. On this graph you are able to see how the intensity of the field of gravity changes depending on the distance from Earth's center. This is all for this video. If you enjoyed the video, leave a like and don't forget to subscribe for more content on this channel. Have a nice day.